How could families survive brutal winters that freeze exposed skin in minutes, without electricity, without metal insulation, without modern heating, yet remain warm, dry, and functional for months at a time? The answer is not toughness. It is not luck. And it is not primitive improvisation. It is one of the most refined cold weather shelter systems ever created by humans. The Great Plains of North America are often imagined as wide open grasslands, calm, beautiful, and endless beneath a vast sky. But in winter, this same landscape turns hostile, merciless, unforgiving. Temperatures plunge below 30 degrees Celsius, cold enough to freeze exposed skin in minutes. Unbroken winds race across the plains with nothing to slow them, stripping heat from bodies and shelter alike. Trees are rare. Wood for fuel is scarce. Stone, when available, traps cold more readily than warmth. By every modern standard, this is a place where sustained human life should fail. And yet, for thousands of years, it did not. Indigenous Plains nations, including the Lakota, Cheyenne, Arapaho, Blackfoot, and Crow, did not simply endure these winters. They lived within them. Children were born and raised. Meals were prepared. Tools were repaired. Stories were told while snow buried the land outside. This survival was not the result of brute endurance or desperate improvisation. It came from something far more powerful, a complete environmental system shaped by observation, memory, and refinement across generations. At the center of that system stood the teepee. To modern eyes, a teepee may appear simple. A cone of wooden poles. A skin stretched tight. Temporary. Almost primitive. That assumption is dangerously wrong. A teepee is a carefully engineered structure, load-balanced, aerodynamically stable, and thermally adaptive, designed for extreme wind, deep cold, and constant seasonal movement. It does not fight the environment. It works with it. Its conical shape allows wind to flow around it rather than crash into flat walls. Force is shed, not resisted. The weight of the structure is driven downward into the ground, not outward against fragile joints. At the same time, the form encloses maximum living space with minimal exposed surface area, reducing heat loss in brutal winter conditions. None of this happened by chance. Every pole angle, every lashing point, every seam in the hide reflects centuries of environmental feedback. Storms survived, failures remembered, designs refined. And here is the detail most often overlooked. Teepees were owned, designed, and built by women. Not as assistants. Not as helpers. They were the engineers of survival, carrying architectural knowledge that determined whether a family lived safely through winter or did not. Before warmth could be created, strength had to exist. Not comfort. Not decoration. Strength. Construction began with 3 or 4 long lodgepole pine or cedar poles, often rising more than 20 feet in length. These were not chosen at random. They were selected for flexibility, resilience, and the ability to bend without breaking under pressure. The poles were bound together using buffalo sinew, an organic material that, when dried and prepared correctly, rivals or exceeds many modern synthetic cords in strength. This was not rope. It was living material transformed into structural technology. This first assembly formed the tripod, the structural heart of the teepee. Unlike modern shelters that depend on tension and rigid joints, the tripod created compression stability. The more weight and wind the structure faced, the tighter it locked itself together. Stress did not weaken it. Stress strengthened it. From this core, 12 to 15 additional poles were added in a precise, practiced order, each leaning inward and transferring load back to the tripod. The result was a unified skeleton, flexible, resilient, and extraordinarily stable. Once complete, the frame could withstand winds powerful enough to flatten modern camping shelters. But survival on the plains required more than strength alone. Because structure can resist the wind, yet still surrender to the cold. The outer skin of a winter teepee was not fabric. It was engineering, Between 10 and 20 buffalo hides were required to form a single winter covering each one, the result of weeks of skilled labor and deep material knowledge. Nothing arrived ready-made. Every hide had to be transformed. First, all flesh and hair were scraped away by hand. Then the hide was softened through brain tanning, a process that used natural oils to break down fibers without destroying their strength. Buffalo fat was worked deep into the skin, creating a natural barrier that repelled water while preserving flexibility. Finally, the hide was smoked, locking in softness, preventing rot, and protecting it from insects and decay. This was chemistry without formulas. Material science without laboratories. The finished hides were sewn together using sinew thread and bone needles, forming seams unlike those found in modern textiles. When exposed to moisture, the sinew absorbed water and swelled, pulling the seams tighter and sealing gaps against snow and rain. The result was a surface that breathed while remaining waterproof. Moisture escaped from inside. Cold stayed outside. But winter on the plains demanded more than a single protective layer. And here, the teepee system revealed just how advanced its design truly was. Summer and winter teepees were never the same structure. Cold demanded its own design. When winter arrived, families installed an inner liner, a second wall suspended inside the teepee, rising roughly 7 feet from the ground, and weighted at the base with stones. This was not decoration. It was engineering. The liner transformed the interior into a sealed living chamber. Between the outer hide and the inner wall formed a pocket of trapped, motionless air, what physicists call dead air. One of the most effective insulators known. This is the same principle used in modern cold weather clothing, insulated housing, and thermal walls. But here, it was achieved with hide, stone, and gravity. Snow was then packed around the base of the teepee, but never pressed directly against the outer hide. A narrow air gap was preserved, preventing moisture buildup and material damage while strengthening insulation. Cold was slowed. Heat was held. Some groups went further. Dried grass was stuffed between layers to increase thermal resistance. Others added partial ceilings that trapped rising warm air and blocked cold downdrafts from above. At this point, the teepee ceased to be mere shelter. It became a controlled climate engineered for survival in a frozen world. At the center of the teepee burned a small, carefully controlled fire, ringed with stones. But the fire itself was never the secret. The secret was airflow. Fresh air entered quietly at ground level, slipping beneath the inner liner instead of rushing through the living space. Cold air was drawn toward the fire, where it heated rapidly and began to rise. The liner then guided this warm air upward, shaping it into a steady vertical flow. This created a natural chimney effect, silent, efficient, and constant. At the peak of the teepee, 2 adjustable smoke flaps came into play. Controlled by long exterior poles, they functioned like a damper, opening or closing to direct smoke away from the interior, regardless of shifting wind. Even when the air outside stood still, smoke found its way out cleanly. Some families refined the system even further. They dug narrow tunnels from outside the teepee directly to the fire pit, feeding oxygen to the flames while keeping the living space calm and draft-free. Fire burned hotter. Smoke rose faster. Heat stayed inside. Modern engineers would recognize this as passive ventilation. The Plains tribe simply recognized it as how a home should breathe. Fire did not burn all night. Fuel was too valuable for that. Before sleep, stones were placed directly into the flames until they glowed with stored heat. Each stone was then wrapped in hide and buried beneath sleeping areas, where it released warmth slowly, hour after hour, long after the fire had faded. Heat was not wasted. It was stored. Even movement across the plains did not mean starting over. When camps relocated, hot coals were sealed inside buffalo horns and plugged with clay, allowing fire itself to be carried across long distances. Embers stayed alive for days, protected from wind and moisture. Fire was treated as a resource managed, preserved, and respected. Wood, however, was scarce on the open plains. So Fuel came from what the land provided. Dried buffalo dung, known as buffalo chips, burned hot and clean, producing steady heat with little smoke. Twisted bundles of dry grass burned slowly, functioning much like manufactured logs. Nothing was wasted. Nothing was accidental. Every source of heat was chosen, tested, and refined through generations of survival. Shelter alone could not defeat winter. The body itself had to become part of the system. Winter buffalo robes were taken only from animals killed between November and March, when the fur was at its densest and most insulating. Timing mattered. Material choice mattered. Each hide was softened using brain and marrow, worked carefully into the fibers to preserve flexibility without sacrificing strength. The hide was then smoked, sealing in water resistance and ensuring durability through months of snow, ice, and wind. The design followed a simple but powerful rule. Fur faced inward, trapping warm air against the body. The decorated outer hide faced outward, shedding snow and deflecting wind. Layering created multiple pockets of dead air, nature's most reliable insulation. An inner calf hide provided softness and warmth. An outer buffalo robe formed a protective shell. Together, they functioned like a wearable shelter. This system allowed people to work outdoors for hours in sub-zero temperatures, moving, hunting, and traveling without surrendering heat. They were not enduring the cold. They were controlling it. Cold weather survival begins with energy. Without calories, even the best shelter fails. Pemmican became the foundation of winter life. Dried meat, pounded into powder, mixed with rendered fat and berries. Compact. Stable. Incredibly dense. More than 3,500 calories could be carried in a single pound, providing sustained energy when movement was slow and hunting unpredictable. Preserved foods were stored with the same precision as shelter. Rawhide containers were suspended from lodge poles, protected from moisture and animals. Underground cache pits, lined with bark, used frozen earth itself as refrigeration, keeping vegetables edible for months. Even the layout of the camp was engineered. Teepees were arranged in circles, with entrances facing east away from the dominant winter winds. Together they formed a shared windbreak, reducing exposure while strengthening social bonds. Inside a single winter teepee, 8 to 10 people lived together. Their combined body heat, reinforced by layered insulation, controlled airflow, and a small fire, maintained interior temperatures between 60 and 70 degrees Fahrenheit. Outside, the world froze solid. Inside, life continued. This system did not appear suddenly. It was not invented in a single moment of inspiration. It represents thousands of years of observation, correction, and refinement knowledge passed from one generation to the next through lived experience rather than written plans. Every winter tested the system. Every failure taught a lesson. Modern culture often assumes that technology begins with industry, with steel, electricity, and machines. But long before any of those existed, human intelligence learned how to work in partnership with physics, biology, and climate. The Plains tribes did not attempt to dominate nature. They did not force the land to obey. They listened. They observed how wind moved, how heat rose, how animals survived, and how materials behaved under pressure. Then they designed their lives around those truths. The most important lesson is simple. Human survival has never depended on control, but on understanding. At Primal Heritage, we explore these forgotten systems, not to romanticize the past, but to remember what human ingenuity is capable of when it works with the world instead of against it. If this story caused you to pause, reflect, or rethink what advanced truly means, carry that thought forward, because the knowledge that once kept humanity alive may be exactly what we need again.